end because, of course, much everyone who uses Java and Java dependencies will use Maven Central. We're going to talk about how it's evolving because Maven Central has pretty much been the same for the last 12 years. Sonatype has been running Maven Central for you all for 12 years. It runs on AWS, so you can imagine our cloud bill is huge. I think per year now we're serving nearly 1 trillion artifacts to you all. So as you can imagine. So yes. And then a little bit of homework. I'll talk about what we want you as a community to help us do when we evolve Maven Central, and then we'll finish off with a bit of Q&A. I don't know where we are now. So this is a field, as you can see. Beautiful. Yeah, lots of trees. Ask any questions.
Okay.
Awesome. This is actually Steve's part, so I'm just winging it a bit here. Should we carry on? Yes, after you.
Thank you. Okay, where were we? Oh yeah. So let's talk about your engagement, right? As a Java developer, or as any type of Java developer, it's all doesn't really matter. It's the same thing. You need code. You need a component. So what do? You go to Google, or maybe Android repository or somewhere, and you type in something. Because that's what you do. You're looking for some. You're probably going, I have a problem, how should I fix it? Stack Overflow or something, it says you should use this, and you go Googling for it, and you're looking for this, what's called coordinates, right? A particular version of something that you can use to install, right? And it doesn't really matter what you use, because Maven Central supports all the different Java build types of system. There are a lot more than you might be realizing, but it doesn't matter. We'll give you any of those that you ask for. You can find that stuff, right? And you install it in your system, etc., etc. Now, when you go to GitHub and you look at how many of these projects there are, there's like 8. This is a bit old. So it's probably about 10 million projects out there that use Java that are on GitHub. And they're all available to you via Maven Central. When you look at a modern application, what you write, the bit that you write is about 10% of the whole functionality. You can't do your job without having this code underneath you, whether it's a framework, an application server, parsers, compilers. All these things come from open source. So it means, on average, about 90% of what you think is the thing you deploy was never written by you, it was written by somebody else. So we all rely on open source, don't we? Because it's what it's there for. It's there for it's being shared by other people for us to use, and we do. We leverage that, right? And then you put the dependencies in, you use this wonderful open source, and you build, and that happens. What happens? Stuff counts, stuff downloads, right? And it's coming from Maven Central. People don't, you just put it in, you type it, you don't even think about it, but Maven Central is just there. And it's been there, like Jamie says, for years. Right? When you get this picture, when you get this happen to you, you're going to go, okay. A lot of people go, okay, I put in whatever dependency I want, and I do Maven compile or something, and this happens. What's happening here is you're getting the code that you asked for, and you're also getting all the dependencies that it has, or its children, or its requirements, and their requirements, and their requirements, and their requirements. So when you pick something, you get everything else that it needs.
So this is Spring Boot, which I presume a lot of you may use. As you can see, lots and lots of stuff.
Yeah. So this comes from a tool that, it was a demo tool we asked. It may come back, but it's really useful for us to see the relationships between all the components that we use, because you don't really visualize that. You just go, I'm going to use this thing, and all the other stuff that comes with it, often you don't really think about. They're just baggage. Right? Okay. But what we know is that on average, and we know that I can tell you this, I'll tell you in a second, but we know on average that you get about 150 dependencies for each Java application. So those green lines, if you were building from scratch, on average, it's about 150 of them. So you think about that, that's all the code you're relying on. And every one of those dependencies could potentially release an upgrade. And again, on average, we reckon about 10 a year. So you could be faced with, RS's licenses, but 1,500 updates. And all that data is coming from Maven Central. Right. Yeah, so Maven has been around, been here with us forever. It's not quite since the beginning of Java. This is Maven.org in 1999. Was, as you can see, was a management company. So somebody got there first, way, way back. Right? But actually, it was created by these two guys, Brian Fox, who's sort of pseudo-my-boss, and Jason Von Zyl. These two guys wrote Maven the tool. And they wrote Maven the tool because they're passionate about giving you high quality developer experience. It all came from how can we make your life as a developer easier, every developer. So they wrote Maven. Prior to Maven, dependency management, that was really hard. You had to sort of download stuff and do it all yourself. So they built something to fix that. So they started it way back, and it stayed at Apache because this is an Apache tool. These guys work in the Apache community. It's all open source, and it was Apache. It was at Apache, funded by public donations. It started on a machine under Brian's desk. Right, Maven Central was a machine under his desk, and it got bigger. And the way it was funded for was by asking for money. Right, 2005-ish. It was getting to the point where being under the desk was not a good idea, and it needed to move. So we moved it to something more robust, still funded by developers, right? And today, though, we fund it. 100% funded by Sonatype, right? Because of you, right? Why? Okay. Because Maven Central has been from something that you could run under the deck to being a critical internet resource for developers. You imagine why you would be if Maven Central disappeared, right? So you have to look at the scale of it. The way it works is pretty straightforward. There's three routes. There's a publisher route. So only a fraction of people publish to Maven Central, and there is a process for doing that. And the good thing is, maybe the good thing from our point of view is, what's behind Maven Central is all the tools that we sell. So repo and firewall and lifecycle and all that sort of stuff, where relevant, is part of Maven Central. And that actually turns out to be important because of some of the things we give you. But basically, there's three routes in. Well, there's two routes in and one out. So publishers push stuff in, there's a bunch of scanning, make sure it's okay. Jenkins' job pushes it in the big bucket because it's just a big disk. You guys come via Fastly because then we can cache it and push it to the edge. And then there's a search process as well, right? So nothing particularly complicated in this. It's a very simple system. It's just big. Right? Oh yes, and there's an API. Most people don't realize there's an API. They just go to the search engine. Okay. But you can go find there's an API, which is quite clever. Right. So let's look at scale. Let's go back a couple of years. So in 2022, we had 8 million, 9 million things. You know, I showed you that search on GitHub, right? We have 9 million versions of stuff, right? 27 terabytes, quite big, right? 80,000 people publishing. It's a lot. That's why it was scaling, right? In 2022, we served 500 billion downloads. That's in 2022. 500 billion downloads. Which, if you can imagine, that's why we can't put it under Brian's desk anymore, because it would overheat. And his pipe, because he lives in the middle of nowhere, the broadband just wouldn't hack it. Right. Now, some of the stuff I'm going to show you comes from insight that we get from Maven Central and other places. So I showed you some of the data there, the download numbers and stuff like that. If you're interested in more, we publish once a year, State of the Software Supply Chain. There's a bunch of stuff in there. It's completely free. It's an analysis of all the data that we gather, because it isn't just about downloads. It's also about behavior. It's all about what happens in GitHub repos. It's what developers do. We have a lot of data about how you behave. So for instance, if you all decided to upgrade to the next version of something, right, and then the day after you moved to the next version, you went bump, bump, then somebody else coming along, we could tell them, don't go to that first version because everybody else went really quickly to the second version. Why don't you go to this one? This one is more stable. And so we have that sort of insight. And a lot of that statistics comes out in this State of Software Supply Chain. You go to Maven Central, you go to Sonotype, and you can have a look at it. It's not even a download. It's a series of web pages. But we use some of that data here. And it tells us what's happening. So 2022, where are we? Java, 450 billion. 2023, double. I know it says 25%, but it's double. Right? 1 trillion downloads from Maven Central. 1 trillion. And then JavaScript, 2.1 trillion downloads. Right? .NET guys, okay, you're behind, 162. Right? Python, 261 billion, growing. The amount of open source that's out there is just growing phenomenally, as you can see. Right? Yeah, so we serve all this stuff up. We provide on the Java space. We provide all this capacity to it, and we do it for free because it's what Brian, who started the company, said we're here to do. Right? And also it becomes a great demo to say, we have our tools behind it. But that's where we are so far. Right? So there's something else that costs us, and that's keeping your application safe. Because having a repo, a disk, isn't great. You know, anybody can do a disk. That's not the value you're looking for, right? The question you have to ask yourself is, when you download something from it, how safe is it? What's the difference between downloading from Maven Central or doing a wget from somewhere? Well, when we ask people to push stuff up to Maven Central, the first thing we say to them is, prove that you own the domain name that matches the packages that you're pushing up. So if you have packages that are org.foo, you have to demonstrate that you own the domain org.foo. And that simple protection keeps most of the bad stuff away. Because so many of the other repos out there, and there are other Java repos as well, not just Maven Central, don't have that protection. So anybody can push anything up. But Maven Central keeps you safe because we ensure that, at least at one level, people have got to prove that they have ownership of that code. And that makes a difference. Right? So by having ownership, it reduces malware. We've had, in the years that we've been running this, we have one instance of malware. Because everything else we can detect. So there are things called, there's different types of attack. One's called typo squatting, another one's called, what's it called? What's the one? Typo squatting. Yeah, what's the other one? Dependency confusion. Dependency confusion. So here we go. So you look at these package names, org.apache.logging.log4j version 999999, right? That is called dependency confusion. On some packaging systems, I could be the owner of org.apache.logging.log4j and publish version 1. And Jamie, nothing to do with me, could publish the same thing at the version 99999. Totally separate. And then when you came to download it and you said, give me the latest version, you don't get the latest version from the authorized author, you get whatever malware Jamie's inserted because he's published high level. Maven Central stops that happening. You can't do dependency confusion because you have to prove you own the package, so you can't have two people publishing it. Okay? If you're in the Python space or the Node space or whatever, this is a real problem and it exists today, so be careful. Typo squatting. Well, typo squatting at one level has dealt with. So this is org.apache.logging.log.j4. So typo squatting is when you type in the dependency information, those coordinates, and you spell it wrong. And then rather than being told that something doesn't exist, somebody has already created a package that matches that misspelling. Now, if it's like this, org.apache.logging.log4j, then we would protect you because org.apache is a high-level domain and somebody has to own it. Somebody can't spoof you intentionally. But typo squatting at the top-level domain, so org.apache, can't prevent that if somebody registers that domain and wants to go to the effort. But most of the time, it's not had any instance of that, and we can spot it. Right? It's not impossible. It's fairly straightforward to see whether there's any typo squatting going. But all these things are protections that you get from Maven Central. Yeah. Okay. And on the other side, like Python, we're always Sonatype is always doing takedowns for Python code because we scan all those repos as well. We don't serve them, but we try to do as much as we can. And we're always doing takedown requests for bad Python code because there are malware bots out there pushing these things up. So this stuff, dependency confusion, typo squatting, etc., is a real thing outside Java, and you need to keep an eye on it. Right. So everything else, because that's easy, because that's fairly straightforward. Everything else is really hard, right? Does the package that you select contain vulnerabilities, right? How do you figure that out? You know, do we stop code being published if there's vulnerabilities in it? No. Everybody asks that. If you have a major vulnerability, why do you still publish it? We continue to publish it because it's only a vulnerability in certain circumstances. It has to be executable, it has to be found. And anyway, there are people out there who need to access it so they can write test cases for it, stuff like that. Right? So we never take down packages from Maven Central that have vulnerabilities, because to be honest, we'd be taking them all down. But unless it's got malware, we will not take something down. Okay? So everything that goes up to Maven Central is scanned with all our commercial scanners. You get all the protection, and we have really, really good protection. And this is so I'm not trying to sell you this, I'm just trying to tell you what you get. Maven Central, significantly better protection, I think, than any other Java scanners. Right. So there's loads of information there that you can use to pick something, right? So you come to Maven Central with the idea of downloading something. Well, you go have a look and see what the latest version is. Go see what vulnerabilities in there. All the information you need to make a better choice is available to you, right? Yeah. Okay. Where are we handing over?
Yeah, this is where I come and scare you and tell you why this matters.
Yes. Okay. I'll flip over.
Thank you, Steve. So yeah, my part is to essentially scare you all into paying more attention to this stuff with some scary facts. So Sonatype at the moment, just our company has discovered, it's actually higher than this, it's nearly 300,000. We have discovered ourselves 200 or 300,000 malicious packages, right? So we have to raise CVE to this, we have to raise takedown requests with the Python repositories, the Node repositories, so it's a lot. And this was between 2019 and 2023, so this has increased since then. So this is a graph which essentially shows you the average amount of vulnerabilities that are downloaded per country in the world. Unfortunately, India is not great, as you can see. It's the second worst, but of course there's a lot of people in India. But yes, it's a crazy amount of vulnerabilities we download all the time. So here's the scary facts part, right? So in 2016, cybercrime surpassed the drug trade, okay? Cyber criminals were making more money than all the drug trade in the world, okay? That is 450 billion US dollars a year, 14,000 US dollars a second, okay? And that's equivalent to 50 of the world's biggest nuclear aircraft carriers, okay? That was in 2016. Do you think it's got worse? Of course it's got worse, right? In 2024, we're now looking at an estimated 9 trillion US dollars, right? that is equivalent to 1,000 of these nuclear aircraft carriers. I think the United States has about 8 of these Nimbus craft.
There's only about 50 in the world.
Yeah, about 50 aircraft carriers in the world, and cyber criminals can pay for 1,000 of those per year, right? This isn't in total, this is per year. And if cybercrime was, so this needs to be swapped, oh yeah, so India's overtaken the UK, I did swap that round before the presentation, but if cybercrime was the GDP of a country, it would currently be the 3rd largest in the world, right? So this is a crazy amount of money that these criminals are making. And if this guy, if he was still alive today, do you think he would be in the drug trade? No, he would be in a basement with lots of cyber criminals making money, because we all know what happened to him, right? But cyber criminals, they very, very rarely get caught, okay? And we've noticed things changing, okay? So this was from IBM X-Force. They, in 2006, when a vulnerability was announced, we had, on average, about 45 days to fix that problem before we got attacked, right? What we found out with Log4j, for example, in 2021, is we had less than a day. When that vulnerability was announced, people were being hacked all over the world that same day. I remember it very vividly. I was working at IBM at the time. It was around Christmas time, and we were told, you are not allowed to go home. You need to find where this vulnerability is in all the applications. And you can imagine IBM with a workforce size of 350,000 people, lots of different products, lots of different applications, especially in the Java space. It was a scary time, okay? So we had to go through and figure all this out. Now, 20 years ago, we didn't use much open source code as we do now. But nowadays, open source code is in everything. It's in insulin pumps that are keeping people alive, right? It's in aircraft, it's in self-driving cars, it's in trains. I think Steve mentioned earlier, 90% of the applications we ship is not our code. We didn't write that, we had just borrowed that from the internet, and we've just assumed essentially that that's all okay, okay? And unfortunately, we as developers, we're not the quickest to react to these things. So, of course, like we mentioned, we run Maven Central, we can see who downloads what version of everything. This was a few months, I think it was about 3 or 4 months after the Log4j vulnerability was announced. Of course, everyone's scrambling to try and remove this version from their applications. And that was about 51 million downloads. So 51 million downloads of the world, like the worst Java vulnerability in history, okay? That got worse. What do you think it is today? So now it's about 22%, and that number is actually incorrect because it's now 350 million downloads. Now, there is a dashboard. You can go onto Sonatype to see this. We can see exactly how many times this vulnerability is downloaded, but that's a crazy amount considering this was the worst vulnerability in Java's history, right? So as you can see here, this is basically a list from the US government of the top exploits that China have exploited over the years. And as you can see, Log4j is #1, right? There were some others that surprised me, actually. I didn't know Atlassian had a really bad one and VMware. But again, this Java vulnerability is one of the biggest exploits out there.
And can I just say, and what you're saying, do you understand? It's still active.
Yep.
Right, 22% of downloads means what? 1 in 5 of you may be still downloading Log4j at work.
And that number isn't all time, that's over the last 7 days, right? So that isn't 22% of all Log4j downloads in time, that is in the last 7 days, 22% of all downloads of Log4j have been that vulnerable version, right? And there's no excuse for that, because we did some research and found out that for every vulnerable version there is, 96% of the time, there is an unvulnerable version of that dependency available, okay? So 96% of the time, there really isn't an excuse to have a vulnerable version. And that's the thing. So we've got to be careful because we're using all of these dependencies from people all over the planet, but only about 11% of all open source projects are actually maintained on a regular basis, okay? So we're downloading this stuff and people are not maintaining it anymore. So where they're maintained, yes. So it's not good if, say, for example, a vulnerability comes out and it takes them 90 days to fix something, okay? We need these fixes, we need these vulnerabilities fixed as soon as possible. So if you're using libraries that are generally not maintained, it's probably worth thinking about moving to something totally different. So people ask why we don't remove this stuff from Maven Central, right? But if you can imagine, if we took that vulnerable version out, because bear in mind, a vulnerability is not malicious. A vulnerability is a mistake in the code where a vulnerability has been found, right? Malware is specifically malicious. That is generated and put there to be bad, okay? So we don't take stuff down because, as we saw, we would break 22% of everyone's builds in the world, right? If we took that version down, okay? But with Java, you're a little bit safer, because in Java, you have to hit essentially the method or the line of code that has the vulnerability in it to be vulnerable. Whereas other languages like Python, you do npm install, you can hit that vulnerability straight away as soon as you've done that install, okay? There are other ways, like you can put stuff on the class path with Java to get it, but essentially Java, you have to kind of hit the vulnerability to be vulnerable, okay? And there's lots of different things coming out around the world. So OpenSSF have created the concept of a scorecard. So a scorecard essentially allows you to look at an open source project and see the health of it, okay? So we can look at open source dependencies, open source projects, and essentially see if they're healthy. So if a vulnerability comes out, how often are they updated? How many vulnerabilities are in there? Do they follow the, regular security practices? And it's not that difficult. So we've done some research to see what are the main things that OpenSSF and some of these open source security foundations look at to determine the health of an open source project. And for example, some of them are like, have code reviews, right? Review code before you put it up. Have a second pair of eyes look at something. Don't fix dependencies to a certain version in your project, because there may not be vulnerabilities today in that version, but that doesn't mean they haven't found them yet, right? They could be out tomorrow. And another example is a lot of companies use the National Vulnerability Database, okay, to get their information about vulnerabilities. There is currently a 2-month backlog of requests to get into that database, right? So there's just vulnerabilities that are not in that database yet. Now, luckily, Sonatype, we have our own database. We do not rely on the National Vulnerability Database. We've actually corrected 33% of that database, because a lot of the time it's wrong. They will either raise CVEs that are low priority, which should be a lot higher priority, and the opposite way round. They could raise them as really high priority, and we're like, no, it's not as vulnerable as that. So there's very simple things to get started. But essentially, if you kind of go onto, supply chain reports, it will give you a list of things to think about when you're picking dependencies, because it makes more sense to think about this before you put them in your application, rather than build an application where you don't know about the open source projects, and then all of a sudden you've got loads of vulnerabilities and you've got to find replacements, right? So it makes more sense to think about this stuff early on when you're starting to create the applications, rather than later on. So have the bad guys evolved? Yes, they have. So traditionally, the cyber criminals, they were out to make money off us all, okay? That was their main aim. Whereas now what we're seeing is government-backed organizations are attacking us, okay? They're not doing this for money. They're doing this because they're trying to attack different nation states. They may be trying to hit your power grid. They may be trying to stop your medical production of medicine. And they may be just trying to simply disrupt your kind of supply chain in terms of food and things like that, okay? And they're getting clever. Some of these people are playing the long haul game. Just because they get into your system doesn't mean that all of a sudden they are going to attack you, right? They could hide in your system for months, even years. Now, there is something that came out very recently. What was it called? The one where...
The XZ one.
Yes. This person pretended to be a committer on an open source project for years, right? And then all of a sudden, he put malicious code in, and then people started getting hacked, okay? So these people, they're not doing it straight away. They are playing the long game now. And this is happening more and more and more. So again, the field of battle's growing, right? They're trying to find new ways to attack us, because our firewalls are pretty strong these days, right? The days are gone where people could just hack through a firewall and get into our networks. So now they're doing a lot of social engineering in different ways. So like Steve talked about, we've got typo squatting, dependency confusion, but there's lots of other different ways. For example, guess what? All our build tools, they've all got open source code in. 90% of our build tools is open source code. So they're trying to get vulnerabilities into our build tools as well. So it's quite scary, all the different ways that these people are trying to attack us, okay? But Maven Central, we're trying to evolve it as much as possible to give you more insights before you actually download these dependencies. It was quite funny because Maven Central, before Sonatype redesigned the look of it, looked like it was built in the 90s. I don't know if you all remember, it had the 3 lines, the Maven Central logo. And when we actually changed it and put the Sonatype logo, bear in mind, it's only a little Sonatype logo up there, everyone was like, oh my God, Sonatype runs Maven Central. Yes, we have been doing that for 12 years, but we had to update it to make it look a little bit nicer. But there are certain things like Sigstore and other things in the background that we're trying to implement this year to make you even more secure, okay? So yes, like I mentioned, Sigstore supports. Who's heard of S-bombs here? Put your hand up. Anyone heard of software bill of materials? One person, okay? So if you work for a lot of so in the EU and in the US, they have now put laws in place to demand that if you sell software to them, you must provide something called an SBOM, which is called a software bill of materials, okay? And essentially what this is a document of, in time of exactly everything that's in your application, all the dependencies. Because what's happening is we as software engineers are not being held accountable for bad stuff that's happening, okay? So think of a car manufacturer, okay? If a car manufacturer built a car and the wheels fell off, straight away, they would be held accountable for people that got injured, okay? People that died, that would be the car manufacturer's fault. But we in software aren't really held reliable for that. So governments around the world are essentially trying to implement laws, mainly at the moment I think India's partnering with Australia and a few other Asian countries. EU has got a really strong law, and the US has implemented a law to say, now we're accountable, so not just the companies, but the people that work for these companies, not only can they be fined, but they can go to prison, all of us, right? And it's not a set fine of, say, $1 million, it's 10% of global revenue of our companies, right? You can imagine how massive that amount is. If you do not abide by these rules, your whole company can get fined 10% of its global revenue. So, basically we're trying to implement stuff like SBOMs, so you can produce SBOMs straight from Maven Central. We're partnering with a lot of the different security foundations around the world to essentially improve it and give you more insights. But like I was asking, we want you to give us your wisdom and tell us what you would like to see from Maven Central so we can help improve it to make your lives better as engineers. Okay? So yeah, some of the things Sonatype do is essentially our products scan your code, scan your dependencies, give you better insight into essentially what to use. Because like Steve mentioned, just because everyone's moved to this version doesn't mean that's the right version to move to. Because we can see that they've all moved to this version, but the next day there might have been a bug, there might have been a vulnerability, and everyone moved to the next version, okay? So we're trying to give you insight in our products to do these things. And this is basically what this horrible graph is here. It basically gives us insight of where you should move to, because moving to latest is definitely not the best thing to do. Just because there's no vulnerabilities in the latest version just means that they haven't found them yet, right? So it's not always good to move to the latest version of everything. Sometimes it's good to be back a few versions. As long as it has the functionality you need, that might be the most robust version out there. And yes, 8 rules of upgrading. I think I've got a better, oh no, I'm missing that slide. But essentially 8 rules of upgrading. Again, don't choose alpha versions, things like that. Obviously, don't upgrade to a vulnerable version, goes without saying. Yes, try and find lower severity versions. I know it can be difficult because there can be breaking changes. Again, that helps if you've got really, really robust testing. Yes, if it's published twice and done in succession, generally go with the later version because there's a reason they've published it very quickly again, and it's usually because they've tried to fix something, okay? So yeah, try and make good choices as soon as you can. So that's about it, yes?
Can I just go over something?
You can do,
because I
indeed.
wanted just to feed into what we were going to say about the trial. Okay. So, Jamie. Okay, I wanted to go back to that because Jamie just missed one point that I wanted to make. Because what we realised is that the people who make the choices about the software that get concluded are you. And the only time that good choices could be made are at the point where you first choose that thing to include. So when you do that first scan and you find something, that's the very first time. Because after that, all that happens is that your company just patches it. It's got a vulnerability, move to the next version. So the only time that anybody thinks about that dependency is at the time that you choose it. So that might make this a little bit more obvious, is that what we're trying to do with all this stuff is take all the information we can about best practices and insight and put it into the tools so that we can give you the best information, so that when you make that first selection, or when you do an upgrade, to be honest, it's more than just, oh, I picked the one that I got on Stack Overflow. The better your choices that you make, the safer you are. And also, it's likely to reduce your workload, because if you pick software projects that have good software engineering techniques, i.e. wherever it was, that thing, like we were saying about doing code reviews and stuff, if you knew that this project has a really good security posture, then they have less vulnerabilities in them in general, so it saves you less effort upgrading it. So what we're trying to do with Maven Central and the tools that we're selling is take all the information that we can and make them available to you, either on Maven Central OSS Index or via the tools. So the tools are enhancing, right? But the idea is to give you as much information so that you can make better choices. And because you just glossed over this one. So the idea of this chart is to explain to you that your choices are quite complicated, because picking, when you upgrade one thing, that might bring in extra vulnerabilities, right? And there are combination of choices. So what we're trying to do is give you not only a point upgrade, but also tell you in context. So what we're trying to get to the point is that when you upgrade, we can say you've got 5 dependencies with 5 vulnerabilities, and the best mix of upgrades for the least amount of work for you will be this, right? And so that's why we're looking at all these rules, trying to help you do that. Right, okay. Now, sorry, I just wanted to be clear about that, because I want to talk in a second about a product that we have for you to try. But what we're trying to do is give you as much information as possible for you to make the best choices. Right. Is it stop?
Is related to the security.
Yes.
You are giving the report, SBOM report,
Yeah.
and also the scorecard. But those are pre-checks. For example, if somebody is using the dependency, they have to go and check themselves.
Yes.
But during the build, let's say when I do Maven build, won't you provide me the warnings? Let's say if I'm using any vulnerable components, why don't you generate a report there itself?
So you can yourself. So Maven has a plugin to generate an S1, right?
Yeah.
Of course, yes, we could do that, but the problem is we've tried and there are stuff that you're going to get, even in the least vulnerable components, there's still vulnerabilities. So you can imagine the output that's going to come through the Maven plugin if we try to do it. It's already massive, right? You do a build, it's so there are ways to do that, and it's one of the things we're looking at. Does the Maven tool actually allow you to look at vulnerabilities? Does it? I think that's where tools.
There are various plugins that you can use that will use different types of data. So it's your choice. But
There's a lot of free data out there.
No,
So
mostly
like
we
this-
do day in and day out Maven build only.
it's like
See, as a developers, we only do Maven build. We don't care others mostly, generally. Don't
Yeah.
care of reports in
So
sometimes.
this is where, for example, certain types of products come in, right? So they sit at every part of your development life cycle, from where you build, through you deploy, etc., all the way to production. So this is how we make money, essentially, right? Is where we scan at every part of your life cycle.
Yeah.
Because Maven Central, it doesn't cost us a lot of money, right? We've got to pay for this.
At least in the build, you give a summary at last so that people can look actively.
Yes, so you can do that yourself. You can generate an SBOM, and then you can basically correlate that with some free tools with open source data, right? But that's, like I said, the National Vulnerability Database is not always up to date, and it's got a big backlog, right? So if you want really robust data and better data than the open source stuff, essentially that's what you have to pay.
yeah, and it's more subtle than looking for vulnerabilities, because the other thing that we capture is what are called CWEs, common weaknesses. So some applications, so a vulnerability is a vulnerability if the project that writes the code accepts it as a vulnerability. They are allowed to be. It's not a vulnerability. If you configure our software properly, you won't hit that problem. So there are software that gets marked as being weak, because though they don't officially have a vulnerability, they may be insecure by default. So you need to know those things. So every time you pick one, because it hasn't got a vulnerability, doesn't mean, weirdly, that it's not vulnerable.
And if it does have a vulnerability, it doesn't mean you're going to be hitting that vulnerability in Java, because you have to hit that specific line of code, right? So imagine we don't want to tell everyone, oh, you're vulnerable, when they're not. They might not be hitting that line of code.
Yeah.
So for example, one of our tools has call flow analysis, so it can see exactly in your application what lines of code you're hitting, and then say, okay, you are actually vulnerable because you're hitting this vulnerable method. But if you're not, then it can say, for example, you're not hitting this vulnerable method, so you're not actually that vulnerable.
Yeah.
Okay? So stuff like that.
Yeah. And then, but we can also tell you where those vulnerabilities exist simply because you're on the class path. So there are vulnerabilities, it doesn't matter, it's not a call flow problem, it's just being there means that you can be vulnerable, so we can report that. Yeah,
It's
anyway.
a good question, because it has been brought up before, and we've thought about implementing it, but it wouldn't make sense, because then we're going to be telling people they're vulnerable when they're not, a lot of the time, okay?
Yeah.
So that's kind of the reason that we haven't implemented it. But you can do that yourself if you want, with paid-for tools like ours, or there are open source free tools.
Yeah.
And you can generate an SBOM at that point, and then feed that into another tool, which is Scan.
Yeah.
Is SBOM licensed right now?
So SBOM is just a kind of document. There's lots of different formats. So there's like zip,
Cyclone DX, SPDX. So SBOM is the list of dependencies that you're
Is
using.
it free of cost right now?
SBOM
Oh,
is
yeah,
free.
no, yeah, so
it's a document.
Yeah, SBOM is
Then
SBOM
you
is
can
a
provide a link in the build command itself at the end, right?
Yeah, so it's
You can
maybe
provide a
plugin
link
that
after.
just generates it as part of your build.
So these are all suggestions maybe for you.
Pardon?
These are all suggestions I'm making so
Yeah,
that
yeah, yeah, yeah.
to make life easier for developers.
well, so that's already there. For generating an SBOM for every programming language and every build tool and every CI, it's all there, right? So because it's easy, right? Joining them together is hard. It's all there, so you don't have to worry about generating them. That's not the challenge. The challenge is always going to be scanning them, because that always comes back to how good is your scanning tools, right? And you're looking for, at the end of the day, what do you want? You want no false positives, and you want no false negatives. So
You don't want to be told 10% of the time that there's a vulnerability and there isn't, and your engineering team goes and looks for something that's not there, because then you've wasted 10% of your time, right?
Yeah.
Whereas our tools, what we say, Sonatype is not publicly, but if it's a false positive, it's a bug.
yeah.
We consider it a bug, so our false positive rate is like 0.1%, or something ridiculous like that. But we don't consider that, oh, that's normal, we consider that a bug.
Second question is, are there any tools for finding the duplicate dependencies and unused dependencies so that the risk of security can be reduced? I don't find any interesting tools in Maven for duplicate dependencies and unused dependencies, especially.
So duplicate, well, there are some Maven plugins that will give you dependency analysis.
Right.
Unused dependencies is complicated, because the unused dependencies, in theory, shouldn't. Well, But there's definitely plugins.
I used that analyze, dependency analyze,
Yeah.
not that great.
So like one of our products, again, I don't want to talk about our products because they're not open source, but it does the core flow analysis stuff, so that will help you know if you're touching those edges.
Yeah, but you can.
These are stuff you have to pay.
Yeah, but you can also, in theory, there's some gross things that Maven plugins will tell you, like this thing's in here, it never gets used. But
So look at what's available for Maven plugins, and you'll probably find stuff about what
Yeah.
dependencies to be in.
Yeah.
But we can't, they don't want to put too much of this in the actual Maven tool itself, because then the Maven tool will get big and bloated, etc. So
Yeah.
it's more up to you to find the plugins to add into Maven.
yeah, and there are lots of them.
Hopefully that answers your question.
I have a quick question. It is regarding when we have a security bug or something, a vulnerable repository,
Yeah.
and we say that this repository is safe. the most problem which a developer faces whether that is backward compatible to the functionality which we are using or not. So finding out, testing every use case, and if it is not backward compatible, it becomes more tedious to find these things. So can we have like these things available? And
That is hard.
Yeah,
yeah,
but-
I agree.
but-
That is
but-
hard, but as you said that we
Okay.
wanted to know what all things you
yeah.
wanted to
So,
see. So
um,
backward compatibility is something which
We do have tools that on the Java side, because Java's easier to check out about backward breaking APIs. So if you were to use, I don't know if it's an OSS index, which is the public one, but definitely in the trial, the products we use, we definitely have that as part of the decision process. And you can see that version of a particular component where it has breaking changes. We don't tell you what it is, but the moment that we can say, yes, it's got breaking changes. And that goes into that advice, trying to tell you what is the best upgrade. Because if we're forcing you to move to something that's got breaking changes, we'll only do that if it's the only way to get out of vulnerability. Right?
And it's hard to figure out breaking changes, right? I mean, even looking at release logs, people don't put everything in release log. It's really annoying. So you can't even rely on release logs because you'll rely on it and then go to use to make it, and it's broken. You're like, why? And they're like, oh yeah, we forgot to mention that. And it's like, what?
Yeah.
So, but at some, like, if you try this trial that Steve's talking about, then it has some of those capabilities of if you move back a version, it won't break. If you move up a version, it won't break, or it will break. So it'll give you a sense of, the effort required to move to these versions.
Yeah. I mean, with Java, so with breaking,
sometimes you have to write the code and extend the classes just to make
I
your
know.
code back to the
Yeah.
functionality that it was
Yeah.
using, because you have already shipped that particular thing to the customer and you
Yeah,
can't.
yeah. Yeah, I mean Java we can find a lot of breaking changes programmatically because it's strongly typed. But other programming languages, I mean, breaking changes in Python or Ruby or something, it's almost impossible. Yeah. Okay.
About the release logs, and then they don't pay everything. The release logs, right? So
Next, yes. Are we? Oh,
two more two more questions.
oh, we got three
Well,
hands.
Someone's got a microphone.
4 hands. Five. Yeah.
Well,
Hello.
You've got the microphone, so you go first, and then you go second.
Yeah. See, one of the biggest challenge with the dependencies is a lot of build time.
Right, yeah.
And I know there are some solutions which we can, this repository we can install locally
Yeah.
at an enterprise level. What do you recommend? Is Sonatype also can be installed locally on an enterprise level?
That's kind of how we started the company, right? We were the first artifact repository, and essentially having that locally inside your organization reduces the amount of time you have to pull down from the internet. If you don't have that, of course you can cache stuff locally. Don't obviously do a maybe clean install because that wipes your cache and will bring everything down again. So caching stuff as close to the developer is best. So using some kind of artifact repository, using AS or one of the others, there's lots of them out there, to put it as close to your developers as possible, and then have your developers cache stuff as well, means you don't have to keep fetching stuff from the internet and require on your internet bandwidth. You can just pull it over your central network, which should be a lot quicker than having to go to the internet. So generally my advice is have a local repository inside your organization and try and get your developers to cache as much as possible as close to them, so on their local machines.
So is that approach really popular, or I still don't see it very
Most
popular?
large organizations will have
Yeah.
an internal repository.
Everybody, pretty much everybody has a Java
For
repository.
example, Red Hat has one built into the OpenShift and things like that,
Yeah,
right? So there's lots of different ways you can achieve this, but basically trying to bring stuff closer to your developers is generally the best way to do it. But it can have loads of other advantages because then you can remove vulnerable version. You can stop your developers going to the outside world and then stop them pulling in vulnerable versions and just having the versions you want. And then you can get everyone on the same version rather than all different teams using different versions of the same dependency and being mismatched and having issues with compatibility. So having an internal repository solves lots of problems, not just the speed as well.
Yeah. So
So that way requirements of an enterprise installation and a central, even the security or, sometimes they may want to put something which should not go to central repository.
Yeah.
So you have these kind of features in Sonatype.
yeah,
Yes.
come and talk to us afterwards.
Yeah,
But
and
yeah,
you don't,
yeah.
there is even a free version of Sonatype. It's called, what's the free version next called? There is a free
OSS
version
repo.
Nexus.
Yeah.
Yeah, it doesn't have as many of the different formats, so you might not have Ruby, etc., blah, blah, blah. But there is a free version for you to use, and you can play around with it and essentially use that as an internal, kind of an internal cache, essentially. So,
Okay. Sorry, we're
this guy next.
Who's
guy
next? One question.
Yeah, it's this guy next. You can do your microphone.
How Sonotype is compared with this Polaris Synapses? No, there is a Polaris Synapses which does the same vulnerability analysis, right?
Oh,
They use the black tech.
But you come and ask us afterwards. So, what you're really asking is how good are we?
Yeah, how
Yeah.
compare with these?
Yeah. So,
Well, I'm not sure about Steve, but
all right. So, 4 things. Number 1 is, can your scanning tool tell you about vulnerabilities in your direct dependencies, the one that you've listed? That's first level. Second level is, can it tell you about vulnerabilities in the dependencies of the dependencies? Third level is, can it find code that's been packaged in a different place? So log4j, could it find a log4j that wasn't in the official dependency, but had been packaged in a fat jar somewhere else? So that's number 3. And then number 4 is, can it find vulnerable code, like a method, that has been maliciously taken out and put somewhere else? So log4j is a good example. The bad class was taken out by the bad guys, renamed, and they inserted it in other places. So that's 4 levels of security. Okay, Dependabot will give you the first level, right? We'll give you all 4.
and the thing is, people are getting clever. They'll move scripts to LDAP servers, so your dependency will pull this script from an LDAP server, it'll run that script, will go to another server, pull something down, and it'll do so much weird stuff that it's very hard to see in the actual code itself. But we have AI machine learning, which we've been using for like 5 or 6 years, so that does a lot of scanning first. And then we have a massive security research team, and these guys, they are amazing. They look at this stuff all day, so they know exactly what to look for, what the bad guys do, where they go. So it just all depends on the tools and the data you've got, right?
Yeah.
So because we've been around in this space, we started this space, we've just got so much data that that's basically.
So, though I'm not supposed to be, not intending to sell you, I will tell you my opinion is, having looked at all the other competitive tools, whether it's Sneak or Checkbox or whatever, we have the best tools. The only challenge is you have to buy them.
Yeah.
Right? But you get the best protection.
We have to pay for your Maven
But
Central
that-
somehow, right?
But,
So-
yeah, but that 4 levels, take them away and think about what these tools do, because if you're relying on Dependabot to tell you your vulnerabilities, then you can be very badly broken.
Right,
Right.
quickly, Steve, do you want to talk
Okay,
about this?
right,
'Cause
so-
we're over time.
Yeah, sorry. So 2 things. We're running this trial. We have this sort of a small version of all of the tech that we were saying. So you can sign up for that. It's a SaaS thing. It'll probably take 24 hours for it to deploy. But then you can upload your application. You can measure it because you can follow the weird instructions. But what we just said about what can we discover in your application, you can upload your application to this and scan it, and we'll tell you what it is. And if you include some of the plugins, like the IDE plugins and things, we can help you like update your POMs and stuff like that.
And it can you can attach it to any GitHub repo, scan the GitHub repo, and tell you how vulnerable you are,
Yeah.
right? So even if you don't use it, continue using it. It's a good thing to just get an idea of kind of how vulnerable some of your applications are, because then that can make you go forward and think, okay, we may need a different approach to how we develop stuff, because maybe we need some tools in the future to give us more insight.
Yeah, cool. So that's number 1. And then the last thing is nothing to do with Sonotype at all. This has been with my Java hat on. 10xjava.dev. I am crowdsourcing a 10x Java developers book. We're asking all of the people in the industry who have wisdom about how to be a better Java developer, and we're trying to get it together into a book. It's at that URL. I would ask you can, because it's GitHub issue driven, if as a developer there's anything you go, I really wish somebody would tell me how to do this.
Or something you did wrong and you don't want developers to do in the
anything
future.
like that, we'd love you to raise an issue. Okay, if you want to know something about tech, if you want to know something about how to interact with people, if there's anything, I wish somebody would tell me this. I would. Okay, or if you're a little bit older, and you go, I just wish whenever we hire somebody, they knew this thing. Could you just come along and put it on as an issue?
And we'll give you kudos, and then you'll get free book.
Yeah,
Right, so.
yeah. So we're trying to crowdsource this. It's early days, right at the beginning. We've got beginning to get a lot of the DevRel guys and the celebs in the space to contribute. All proceeds, well, most proceeds will go to Fujay. So yeah, that's
Fujay's a website like Friends of Java, like an open source OpenJDK website.
yeah. Anyway, and if you, I have posters, pieces of paper with these pictures on.
Yeah, so you don't need to take a picture of this, it's fine.
Right,
We've got.
and I think we've overrun. Thank you very much for your time.
And last but not least, there's loads of cool stickers over there, so everyone help yourself. But yeah, thank you very much for listening to us today. It's been a pleasure. We love coming to India, so yeah, thank you very much.
Looking.